The next time, that's your responsibility.
All right, are you already recording? All right, okay. So let's solve. The absolute value of 3 minus x is greater than or equal to 2 plus the absolute value of x plus 2. Now, we can do very little. We cannot even combine the various terms here because we have the absolute values. All right, well, walang similar terms eh. Kasi nung x plus 2, the absolute value, the 2 here inside, you cannot add that to this 2 here because nung 2 after x plus 2, well, it's inside the absolute value bars. So the only way we can progress is if we can drop the absolute value bars, which means we have to know the signs of 3 minus x and also of x plus 2. Are they positive or are they negative? And for us to be able to do that, we need to make assumptions on the value of x. So for example, if you look at x plus 2, sometimes this is going to be positive and sometimes this is going to be negative. This is going to be positive when x is greater than negative 2, and this is going to be negative when x is less than negative 2. So x plus 2 turns at the number negative 2. And if x is greater than negative 2, which makes the absolute value of x plus 2 positive, then the absolute value of x plus 2 equals x plus 2. On the other hand, if x plus 2 is negative, which happens when x is less than negative 2, then the absolute value of x plus 2 will be negative x minus 2. All right, so see what happened here? We were able to remove the absolute value bars. And how did we make that happen? By making assumptions on the values of x. Now 3 minus x turns at the number 3. So the turning points are negative 2 and 3, and they divide the real number line into 3 intervals, A, B, C. Let's look at solutions in the first interval. Suppose x is less than negative 2. What's going to happen is that x plus 2 will be negative, positive, positive. And on the other hand, 3 minus x will start being positive and then become negative when x is equal to 3. So in the first interval, consisting of all values of x less than negative 2, the absolute value of 3 minus x will be just 3 minus x, because 3 minus x is positive. And then this is greater than or equal to 2 plus. Now, x plus 2 is negative, so the absolute value of x plus 2 becomes negative x minus 2. So looky. Now we have an inequality without any absolute value bars. Let's see what this provides us with. 3 minus x greater than or equal to negative x, which means 3 is greater than or equal to 0. What this means is that for condition number 1, x less than negative 2, there is no other restriction that needs to be imposed because 3 is greater than or equal to 0. So for our first solution set, it would be negative infinity onwards to negative 2. Okay, the fact that we ended up with a true statement means that the inequality star, which becomes this, would always be true anyway, because it's being true is tied up with whether 3 greater than or equal to 0 is true or false. Okay, next, suppose x is between negative 2 and 3, interval B. But let me include here, because in case 1, I didn't include negative 2. Let me include negative 2 here, just to make sure that x equal to negative 2 is included somewhere. Okay, in the second interval, the middle interval, 3 minus x is still positive. So the absolute value of 3 minus x is still itself 3 minus x. And then that's greater than or equal to the following: 2 plus, now in the second interval, x plus 2 this time is positive. So the absolute value of x plus 2 is going to be itself. Let's solve this inequality. We're going to end up with 2x, 3 minus 4, negative 1, which means that x is less than or equal to negative 1/2. So what this means is that aside from the assumption that x is between negative 2 and 3, in addition, we have to impose the following condition that x is less than or equal to negative 1/2. So here is negative 2, and here is 3. So these are the values being considered in the second case. However, in addition, we want x to be less than or equal to negative 1/2. Okay, but of course, we're not going to go lower than negative 2 because we have to stay within the assumptions of the second case. In other words, we have to take the intersection of the two shaded intervals that I am drawing here. And that intersection is negative 2 to negative 1/2 with both endpoints included. So second solution set, the closed interval negative 2 going to negative 1/2. Lastly, suppose x is greater than 3, but in case 2, I didn't include x equal to 3, so let me include it here. Now, the first term on the left, the absolute value of 3 minus x. This time, 3 minus x is negative, so the absolute value of 3 minus x will become x minus 3. Greater than or equal to 2 plus the absolute value of x plus 2 is x plus 2 because x plus 2 is positive on this third interval. We are going to end up with negative 3 greater than or equal to 4, which this time is false. So, kumbaga, think of it this way. We are looking at the following two conditions happening. We want x to be greater than or equal to 3, but we also want negative 3 to be greater than or equal to 4. That's impossible because negative 3 is being greater than or equal to 4 is a false statement. So the third solution set is the empty set. So let me compare what happened with case number 1. In case number 1, we had the following two conditions we need to impose. X has to be less than negative 2, and at the same time, we also want 3 to be greater than or equal to 0. But whether we like it or not, 3 is going to be greater than or equal to 0 anyway, which means in case number 1, the only condition we have to impose is that x be less than negative 2. So 3 greater than or equal to 0 is not any additional thing we need to require. But in case number 3, we are forced to require negative 3 to be greater than or equal to 4, which is impossible. Therefore, there's no solution set. So finally, what we take for our solution set is the union of the three solution sets. So kumbaga, we ended up with 3 different baskets coming from 3 different houses, and we want to collect all the fruits from the 3 different baskets from the 3 different houses, because all these fruits together will make up our solution set. So we have negative infinity to negative 2, and then negative 2 to negative 1/2, and then the empty set, we end up with negative infinity onwards to negative 1/2 closed. This is the solution set of our inequality. All right. So yes, even though we're not factoring, we're not multiplying, we're not dividing, we are still interested in the signs so that we can determine whether to just drop the absolute value bar around an expression or to replace it by its negative. Okay. So do try again some of the problems that you skipped. For example, ano ba? Nung number, well, you could try out number, well, definitely number 12. All right. It can be handled that way. Okay, number 12. Oh, also number 5. Number 5 and number 12 are kind of related, are related to each other. It's number 5 is an equation, number 12 is an inequality. Okay, number 6. So let's recall one of the general facts that we talked about last time. So you know how kunwari, I'm looking for it. Okay, maybe it's in the December 12 discussion. All right, here we go. Okay. If the absolute value of x is less than a, it means the distance of x from 0 is less than a. So think of it as describing the following situation. X is close to 0. X is close to 0. So how close? Within a unit. So starting from 0, you can only go as far as up to negative a and as far as positive a. And you cannot exceed those boundaries. So if the absolute value of x is less than a, it means that x is between negative a and positive a. So for example, if the absolute value of 2x plus 5 is less than 11, it means that 2x plus 5 is less than 11 and at the same time greater than negative 11. Now that's different from the opposite situation. This time, if the absolute value of x is greater than a, or if the absolute value of x minus 0 is greater than a, this time the situation being described is that x is far from 0. Malayo ang x sa 0. In fact, here is 0, here is a, and here is negative a. Okay? Magdistansya ng x from the origin 0 farther than a units. So either x is here, either x is, oops, I made a mistake. Either x is greater than a, or, andito, x is less than negative a. So either here on the right or here on the left. So that's why the conjunction is or, okay, rather than and, because if the conjunction was and, then you would be requiring x to be here on the right green region and simultaneously here on the left green region, which is of course impossible. X cannot be in two different places at the same time. So that's why the conjunction is or. So consequently, if the absolute value of 2x plus 1 is greater than 5, then either 2x plus 1 is greater than 5 or 2x plus 1 is less than negative 5. So how is this going to apply to some of the inequalities and equations that you solved? Some corrections would have to be in order. For example, in number 6, so the first part and the second part, both of them. In the first part, you are looking at the absolute value of 2x plus 3 being greater than or equal to 2. What this means is the following. Either 2x plus 3 is greater than or equal to 2, or 2x plus 3 is less than or equal to negative 2. compared to what you did consider 2x plus 3 greater than or equal to 2, which is this. However, the second consideration, the second inequality you should have looked at was 2x plus 3 is less than or equal to negative 2. However, in what you considered as an inequality, the inequality symbol was pointing in the opposite direction. All right. Same as well with the second part. Do you have any questions, Joshua, so far? Sorry, what's that? Oh, well, malinong sign, but I would also want to see clearly, ganito Joshua, kasi you ended up with this inequality and this inequality. When next time you try to solve this, I want to see, ano ginawa mo dito? Did you take their intersection? Did you take their union? All right. So I also want to see that because in fact here number 6, I'm seeing 4 inequalities put inside boxes. So I would need you. So for me to be able to help you see further what you were doing, because how did you end up with this? All right. So if you could write your solutions in terms of intervals, because if you write them in intervals, so kunwari, I would be easily able to see, oh, you took this interval and then you took the union with the other interval. Para makita ko kaagad what you're doing. Because right now, you just put in boxes for inequalities, but I am unable to see how you process them, how you combine them. Okay? For next time. And here in number 2,
Ay, ganun po yung ganun po kahit saan siya, yung sinasabi sa kanya parang kulang yung solution. Sinasabi nga sa physics sa kanya, yung solution is like you're convincing the reader na
yes. Oh.
Opo, ganun. Kasi minsan, lahat, hindi ba mini-mental niya, sabi, we need to see your in steps para...
Right. Over.
Ba't ka po, kunyari po, binigyan ko siya ng problem, tapos sabi ko, hindi na kita kailangan tanungin, where did you get this? Dapat, andun na sa solution mo yun, yung mga necessary things na malaman na magbabasa ng solution mo para...
Okay.
Right. Diba po?
Joshua, there is value in that. As scientists, it is important to be able to come up with these ideas, but we live in a world where we need to communicate these ideas. And for a lot of people, the problem usually is in articulating their thoughts. All right. So you are convinced, that's great, but you also need to convey that. When I talk to my students, the analogy I give is that of a lawyer defending his case before a judge. You don't just go say innocent and make a plea about how you believe in the innocence. You have to prove the innocence of the person. So you have to lay down your arguments in a logical manner. I mean, it's twofold rin kasi. For problems such as this, which are rather basic, you need to articulate your ideas so that you can convey to the people working with you. But when you go to higher levels, you need to be able to articulate your ideas because you need other people to check the correctness of your work. Parang kunwari gagawa ka ng journal article, magpa-publish ka ng paper. All right, it's not enough that you did the experiment correctly. Other people need to be able to replicate the experiment. And part of that is making your data available. Part of that is being clear about the steps that you've taken. All right, so consider this as training in that endeavor. All right, so sulat mo ng in a way that shows us the good ideas you have. All right, so dito naman, 2x plus 3 is less than 5 and at the same time greater than negative 5. So tama to, 2x plus 3 less than 5, pero ito opposite. Kasi dapat 2x plus 3, it should be greater than rather than less than. Okay. Another way to come up with these is ganito, no? If you look at part 1, so the absolute value of 2x plus 3 is greater than or equal to 2. No, absolute value of 2x plus 3, that's either 2x plus 3 or the negative of 2x plus 3. So the negative of 2x plus 3. So kumbaga, you have case 1a and then case 1b. And then these are absolute value expressions which are greater than or equal to 2. And then if you look at 1b, if you move things around, you see what it provides us with. It leads us to 2x plus 3 less or equal to negative 2. So you can think of this other condition inside the box. Saan siya nanggaling? Dito siya nanggaling. Okay? From the negative of 2x plus 3 being greater than or equal to 2. All right? But ultimately, if you have the absolute value of a is greater than or equal to 7, you could go straight ahead, a greater than or equal to 7, or a less or equal to negative 7. Pwedeng dumiretso ka na doon para mas mabilis. Okay. So this is something that you would have to apply on, I see number 6, tapos dito din sa number 13. All right, so meron din sa inequality ng orientation. Okay. Number 14, parang na nagkamali ka kasi number 14, kita mo to, there's 4 minus 2x and you ended up with here. You ended up using, it appears, asa na yan, sorry. I think I saw it just a while back. Ito. Look, 2 minus 2x. All right.
Pag dito sa notes natin po, 2 minus 2x.
Baka ako po nagkamali ng kopya.
All right. sige, check na lang. Anyway, it's perfectly all right. Lalo din naman. So you just, do what you can to all right. So you can always go back to it. All right. Ito si Medyo si Sir pala Si Sir, it's okay. Okay lang, we're not operating on any deadline. So you just work on that when you find the opportunity. Okay. Okay. So would you want me to solve other inequalities and equations of this type, or maybe try to work on the examples yourself first, and then how do you feel right now? Gusto mo subukan muna itong mga other items on your own?
On my own.
Sige, yeah, on your own muna. And then if you're stuck, let's just talk about it another time. Okay. For today, December 15, I wanted to talk about sequences and series. I have to pause every now and then. Dehydrating pag nagsasalita. So, okay lang naman. Okay, always drink water. Oh, by the way, meron pa palang sorry, I just got reminded because you wrote them down. There were some old problems.
Mali pong yun.
Ito nung number 3, nga pala, hindi ko pa natitignan. So, I mean, you've already written down your solution. So, let's, I'm looking at the, here. So, find all numbers x such that ang daming mga news notifications lumalabas, blocking my view. Yeah, I can't see the. Okay, here we go. So for my reference, let me just write down the items, the numbers. 2, 4, 6, 16, and x. Okay. So ito parang casework. So ito x greater than or equal to 6, x less or equal to 4, and then here x is greater than 4, strictly greater than 4, because equality with 4 is already here. And then strictly less than 6, because x equal to 6 is already here. So if x is greater or equal to 6, this is how it's gonna turn out to be. So 28 plus x over 5 equals 6. And then when you solve for x, so 30, x is equal to 2, but that goes against x greater or equal to 6. So, all right, so there's no solution. X cannot be greater or equal to 6. On the other hand, if it's less or equal to 4, nandun siya. So the median is going to be, the median is going to be 4. But
X equals 7 is not it's not in between 6 and 4.
What's that?
7 is not between 6 and 4 po.
7. All right. Sige. So we have -8 so far. Tapos this time, mangyayari if it's x, 5x, 4x, x is equal to 7, but it's not between. All right. So you're correct. So this is enough. Thanks for pointing it out. So wrong. So you're right. So there's only one value of x which fits the conditions of the problem, and it's -8. Okay, so number 3, okay na tayo. Let me mark it above. So we are, I remember number 1, we're okay with it. So now we are okay with it. Number 2, try it again. Pero ganito, no? Now that we have greater clarity, what siguro you could do is consider the turning points so that you could sketch the graph. Like for example, suppose x is, the turning points are 1 and 3. So mangyayari, x minus 1 will be negative, positive, positive. X minus 3 will be negative, positive, positive. So that means if x is less than 1. Okay. Nagsisiksikan tayo dito sa space na to. Let me copy this downstairs. Doon sa baba. So we're gonna be freer. Okay, so okay, we're trying to do something, or the absolute value of x minus 1 plus the absolute value of x minus 3. So mangyayari, because x minus 1 is negative, so the absolute value of x minus 1 will be its negative. But then x minus 3 is also negative, so its absolute value is its negative. So this will give us negative 2x, then plus 1, plus 3, so it's plus 4. Okay, so ibig sabihin, the graph will look like this. If x is less than 1. So here is 1. Y equals negative 2x plus 4 is a linear function. So we can determine how its graph looks like. Well, it's a line. And when x is 1, we get 2, and then when x is 0, it's 4. So nung graph niya, ito nung itsura ng y equals negative 2x plus 4. However, it's not really the entire graph of the line that we need, but only the part of the line for which x is less than 1. So it would just be the part of the graph above these values of x which are less than 1. So that would mean the graph we're looking at is the following. So this red ray is not the entire graph, but only part of the graph. And then next would be, what if x is greater than or equal to 1 and less than 3? How's the function going to look like? And lastly, if x is greater than or equal to 3, how is the graph of the function going to look like? So taking the union would be putting together the graphs of the 3 different functions, putting them together like Lego pieces. The turning points are 1 and 3, 1, 2, and 3. So mangyayari, the second expression that we get here, let's say it also turns out to be a line, but a line in a sense indefinitely in both directions. However, we're only going to get the portion of the line for which x is between 1 and 3. Then lastly, when x is greater than or equal to 3, we're only going to get the portion of the graph for x values which are greater than or equal to 3. So the green portion. So when you put the 3 different pieces together, red, blue, and green, that would then be the graph of our function. Ito. All right. And then, so the task here was visualization. Kasi you're going to end up with a region below the graph of this horizontal line, y equal to 8. Okay. But we needed to know the graph of this first, and it was a task in trying to figure out these various cases so we can rewrite the function without absolute value bars. Okay. And then for the geometry problem, so let me prepare itong number 4. This is straying into less familiar territory. But as I started this batch of problems, I was thinking of case works, looking at different cases. Oops, hindi nag-paste.
Yun po yung mga cases nilagay ko na po yung cases. Pero finding yung area from the is not easy.
Oh, so ayun nga, not easy. So tama, number 1, and sana din paki-label nung So let me copy the figures here on the side. Okay. So median. So we have an isosceles triangle.
Isosceles po siya kasi kung scaling, then there will be a gigantic number of pieces po. Kasi each of them po, permutations.
Oo, kung scaling, ang daming cases dito. So I think mangyayari if you don't have any such assumption, parang ito kasi the fact that you have an isosceles triangle, tapos ito, meron tayong median with length 15 and altitude of length 24. So kasi, as far as this, so ito, my drawing seems to be deceptive, pero ganito. When it comes to the altitude of length 24, either it's this altitude O kaya the altitude of length 24 is this.
Pero wala
Kasi
naman
kasi there are three altitudes. Oh, so some might argue, how about nung case na ganito? But in this case,
siya.
sorry, what's that?
Same na rin po siya sa yung second na piece po.
Yeah,
Kasi-
precisely. So pareho siya. So in fact, so silang dalawa lang, 24. Tapos, so kung
Wala po ako na overload. Dapat po
Oh.
when the altitude and median come from the same vertex. Except from yung ano po, except from yung una po kasi the median.
yeah,
the
except from the first kasi in this case, kung nung 24 na yan, here in case 1, that altitude is also a median. So if you have a median of length 15, then it will have to be ito. So ganito, 15. Now for the second case, okay, kasi pwede na ang median is ito. Pero pwede rin, as you were saying, so meron tayong ito. 24, tapos median is 15. Okay, but the last triangle that I drew, is that reasonable? Is that possible?
I don't think so. Yun nga po yung, I think yun po yung in-argue ko po sa una. Di ba po yung sinasabi ko po na the median is going to come from the same vertex.
Right.
The median is never less than the altitude.
Right. Kasi magkakabuo ka ng ano, tama. I do remember you saying that. Kasi here, you end up with this green right triangle. So 15 would be the hypotenuse. So this is impossible. All right, so then in this case, so ito, to be fair, medyo mahirap na nga ito. So I think the two cases you described, ito yun sila, di ba? 1 and 2. Although sana na indicate mo like which cases are they? Kasi as I look at them, I suppose your case 1 is the same as my case 2 kasi with the way you drew your right angle. But sana kung sinulat mo nung lengths of segments, then that would be clearer in conveying to me which case you are looking at.
Sana kung ginawa ko po is deceiving. Parang siyang medyo equivalent.
Ano yan nung pag ginawa mo ay parang ano?
Mukha po siyang medyo equivalent.
Well, pag nagdududol, nagsa-scratch work, okay pa lang so far eh. Pero ang importante, ang next step would be to think of a strategy. Ako siguro gagawin ko dito, I'm gonna call this X.
Pero naman po sila, they're both right triangles at this point.
Itong left and right, no?
Opo. Whatever sections of the triangle are being divided by the right angle are automatically right triangles na po kasi may right angle. So it is
So
a
ito.
little easier.
So this right angle. Anyway, balikan na lang natin to next time. All right. So hold on. Okay. Sorry. Here. test, sequences and series. So not that we're going to be very particular with terms, but a lot of students get confused. A sequence is just a list, and then very much related to that is the corresponding series, which is the sum. Are you familiar with summation notation?
Yung sigma.
Right. So when you write down, kunwari, A7 plus A sub 8 plus A sub 9 plus A sub 10, this can be written as the sum of A sub I, as I runs from 7 up to 10. Kasi I is being replaced by 7, 8, 9, 10. I is what we call a, sorry, what's that?
Bakit po ba ito indicate as I when there's literally an I na imaginary unit? Tapos gagamitin po nila yung same na, ano po yung parang font, yung parang italics pa rin po. So, it is practically indistinguishable from yung ano po. Yung,
sorry, what's that? Okay, so two things. Number one, the imaginary unit. Bakit ginagamit nung I? Well, kasi just like with language, sometimes, you know, no mga past tense, there's really no single rule that follows. Sometimes we rely on standard. So I would imagine the reason for using I is because it's the first word of it's the first letter of the word index. Okay, and itong I that we're using here, we sometimes refer to this as the index of the summation. I mean, that's a term that I encounter every now and then. Okay, pero in fact, this is not the only situation where a symbol is used for different purposes. So for example, 3, 7 could refer to a point with x coordinate 3 and y coordinate 7, or it could also be used to refer to an interval. The interval whose values consist of, well, values of x which are greater than 3 and less than 7. So we just look at the context to see what is being referred to. So in this case, in a summation, we are not doing any computation summand involving complex numbers. But of course, if one wants to look at I cubed plus I to the fourth plus I to the fifth, then you should use a different index, k. Right, k from 3 to 5, and then I to the power k. All right, so of course, in such a situation, you should avoid using I for your index of summation. I wrote here, I is a dummy variable because you can replace it with some other letter and it would not change the meaning. So we could write this as the sum of A sub j, as j runs from 7 all the way to 10. You can also write this as A sub k, as k runs from 7 all the way to 10. And then, of course, you can also write this in the following manner. Let's say A sub I minus 1, where this time I is going to run from 8 all the way to 11. Do you see that? All right, because if I is 8, then I minus 1 will give us 7, which is the first subscript. And then if I is equal to 11, then the subscript I minus 1 will be 10, consistent with the last subscript we are seeing here. All right. So sometimes some of my students get confused with, yes, you were asking? What's your question?
Sa arithmetic series, yung sum po, parang ganun po, basically parang A7 plus A8. May summation po. And then for geometric series, A7 times A8, diba po? So may product summation. Pero why is there no such thing as summation na harmonic or something?
For what?
Why is there no such thing as a harmonic summation or something?
What do you mean, why is there no summation for harmonic?
Kasi po, kumbaga, yung summation po corresponds to arithmetic series. Tapos
Not
yung
necessarily, not necessarily.
Not necessarily.
No. Kasi ganito. When you're talking about summation, you're talking about the operation of addition. You're talking about the operation of addition. I mean, we still have a geometric series because we can add the terms of a geometric series. It's just that the terms of a geometric series are built up using multiplication. But if in the end what you want to do is add all the terms of a geometric series, then we're still going to use summation notation. Is that your question?
Yung kaya sinasabi ko po, kung baga ganito po,
Nakakasabi.
di ba po, pag ina-add niyo po yung terms, summation, yung product ano naman po, may product summation pag minimultiply na po yung terms.
May product notation. Are you talking about this?
Yung pi po, yun po,
Yeah.
product summation. Tsaka, is there any other summation for another operation? Exponentiation po. O kaya yung harmonic ano po, harmonic summation.
You could always come up with a notation. I think ultimately it's an issue of what often ano nung kailangan in a predominant manner. Kasi if you're gonna invent notation, tapos you want it to be used by a lot of people, then it better be notation that's gonna be used a lot, that's gonna be used frequently. So in fact, if you look at some calculus books, itong notation na to, parang minsan nasa mga appendix na lang to or additional exercises eh. Kasi while we are familiar with this notation, it's not used as often as the summation notation.
Pero nakita ko po, kind of often naman po yung ano eh. Di ba po 1 over an arithmetic series? What if pala, pwede pala, 1 over yung summation. Ayan. Clear that na.
Ayan. So kasi meron ka ng ano eh. I mean, I'm not sure what you mean kasi by harmonic. Are you talking about 1 over 1 plus 1/2 plus 1/3 plus so ganyan? Or are you talking about 1 over 1 plus 2 plus 3 plus 4? Are you talking about the former or the latter? But the thing is, if it's the former, you see the operations involved are still sums. So you can still write this as the sum of 1 over n, as n runs from 1 all the way to 4. And then the second, 1 over. So kumbaga, merong nag-exist na notation, and if your current need is not addressed by available notation, then maybe that's the time that you devise new notation. But otherwise, kung kaya pa naman i-address ng currently existing notation, I think the verdict would be to, for now, rely on the already existing notation.
Parang ano po, yung notation, something that should make it convenient for people to solve or remember. Di ba po? If you're able to devise something which is more useful for people, then perhaps it could be accepted as that better than you were notation. But if it's making everything more complicated, then you stick to the current na po.
Yeah, but by all means, actually, may social aspect ito eh. It's kasi you're using a standard, so people have to be on board. So yun, even if you make up new notation, if others are not gonna see the need for it yet, then it's not gonna be picked up. All right. So kung may available, kasi like people all need to be on the same page. Like when they see the symbol, everyone knows what it means.
Yes, it's a convention and po.
Convention. Parang ano, when we say add number and versus even number, everybody knows what kinds of numbers we are referring to.
Okay.
All right. So there are, I would imagine, some series that you are familiar with, right? So you are, I suppose, familiar with this 1 plus 2 plus 3 plus ... plus n.
Basta po,
Or the
n plus 1 over 2.
n times n plus 1 over 2. So this is the sum of I as I runs from 1 all the way to n, right? Do you know, have you seen any justification for this formula? Saan to nanggaling?
Gaussian sum po.
All right, Gaussian sum. All right, so since you're already familiar with that, no need to Seguro maybe if later on when you talk about arithmetic series in general. How about the sum of the first n squares?
So, ano po, sa para po siyang, wait na ba? Inisip ko lang.
It's okay if
N plus 1 times n plus 2 all over 1 times 2 times 3, which is 3 factorial 6.
the third factor is 2n plus 1.
Okay po.
All right. What I remember is the following. Okay, ito. The first two factors are n and n plus 1. So if you add them together, they would result in 2n plus 1. So in practice, I mean, for the longest time, I had a difficult time remembering this. But what I would do was the following. So say I had to add 1 squared plus 2 squared plus dot 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 plus 20 squared. So it would be 20 times 21. And then instead of remembering 2n plus 1, I mean, you could do that with n equal to 20. 2n plus 1 would be 41. But in practice, what I would do is look at 20 and 21. When you add them, you get 41. So that's the third factor. And then divide by 6.
Right. Over yung whatever the, ano po yan, yung nakasuot sa, yung under po yung cursor po ninyo.
Sorry, what's that?
Yung under po ng cursor po ninyo, yung exponent po ng I. I squared. So whatever the exponent is, yan ba po yung sa denominator yung exponent factorial po? Denominator.
Not necessarily, kasi ganito. I mean, that could be a start, no? Pero that's certainly worth exploring. Pero ito ba nakita mo na the sum of the first n cubes? I to the third power. This is going to be n squared, n plus 1 squared over 4. So perhaps you were thinking it's going to be, so kanina the denominator is 6, which is 3 factorial. So perhaps you were thinking maybe the next denominator is 4 factorial. That's actually commendable. I like that attitude kasi you're trying to question, ano kaya mangyayari next? Ganito kaya? And sometimes it does happen that how things unfold is what we predicted them to be. But sometimes it's not always going to be that. So it is important. I put premium on, when given formulas, how do we know it's true? How can we prove that? How can we justify that? All right. So ito, you already know where this came from. The second, for the sum of the first n squares, you have encountered this formula before, have you? Na-encounter mo na to before?
Pero yung square na rin po.
No square. Na-encounter mo na. Okay, pero I take it, hindi mo pa nakita nung reason why it's true. And then how about the sum of the first n cubes? Have you seen this? Okay, good, so that, all right. Nahatching ka. How about the sum of the first n cubes? Have you seen this formula before? Hindi pa. All right. Would you like to see saan nanggaling nung formula for the sum of the first n squares?
Yes po.
Sige, parang I'm not giving you much of a choice din eh. Ganito. So y is 1 squared plus 2 squared plus 3 squared plus dot 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 plus lagay natin nung second to the last term n minus 1 squared plus n squared. Why is it n times n plus 1 times 2n plus 1 divided by 6? Okay. Have you heard of mathematical induction?
According sa opposite. So induction po from little yata, little information to information. Tapos yung isa
Right,
naman,
right.
whatever, deduction yun. Deduction po from a
Induction.
lot of information. You will just skim it down to a little. And then yun po yung
Right,
answer.
right. To something particular. Good. You know the distinction between induction and deduction as thought processes. Although mathematical induction is much more specific. So I'm just curious to say I'm also thinking of the other things that we can discuss in the future. Math induction. Have you used this before? Are you familiar with it? Or I guess hindi pa.
Math induction. Ako hindi ko siya alam po. Kung baka na-encounter na, hindi namin po alam na math induction.
All right. Sige. I would take it na hindi pa. So okay, good. No need to talk about it. But it's definitely one of the things that we can do in the future. For now, you are comfortable with algebraic manipulation. Ganito. Oops, I forgot the question mark. Siyempre, question should end with a question mark. Okay.
I just want to emphasize to Joshua po kaya tinatanong ni Sir Richard so that we can, hindi lang yun touch on or you've heard of it mas maganda yung parang kaya dinidiscuss ni Sir kasi so that we will have an in-depth knowledge of the topic, di ba po, hindi lang yung superficial.
Is it
Right.
another thought process in it all, or is it just using induction and math?
No,
Kasi actually ganito.
if you're not sure, then
Iba-iba yung terms.
kahit na kung hindi ka sure, it is worth exploring for me. Kasi kung ako po, sabi ko nga, kahit na sa iba niya teachers, ano po kung hindi niya master, pwede po siyang kahit na tumagal sa topic na yun kasi
Okay lang. Hindi tayo, we're not in a hurry. Hindi tayo nagmamadali. Hindi tayo nagmamadali. Alright. Tsaka you're familiar with some ano na naman kasi some algebra. Kasi kung ang gagawin ko lang, Joshua, ang papasolve ko sa iyo, x squared minus 5x plus 6 equals 0, I think you're gonna get bored, right?
Negative 2 and negative 3.
Yeah, di ba? So alam mo na gagawin eh. Alam mo na gagawin. Part of learning something new is kasi we have to explore as well the things that are new. We may be uncomfortable with it. Kasi if all we're gonna learn, if we are only gonna stay with what we are comfortable with, that's not learning because you're just repeating something you already know. All right. So ito, n plus 1 cubed. Ito, I'm just gonna illustrate the argument, the proof. So for now, medyo siguro malabo pa. Where am I gonna bring this to? But ako dito nagsisimula. All right. But kasi gusto kong pagkatapos nito, I'm gonna prove the formula for the sum of the first squares, n squares. What I'd like you to do is apply the same technique to prove this. And then once you have done it, maybe you can come up with your own formula. What is the sum of the first and fourth powers? All right.
Okay. Magiging, pagkatapos ko lang kasi, yung ano na po solving yung quintic technically po. Wala po pong,
Sorry, what's that?
Yung nag-ano na po, 1 to the 6th plus 2 to the 6th. Pag at that point siguro po, is it possible to come up with a generalized equation? 1 to the n, 1 to the x plus
Learn,
2 to the x.
Joshua, I didn't get everything. Can you say it again? Can you say it again?
Siguro is possible po to get 1 to the x plus 2 to the x plus etc. plus n to the x.
Right, kung papalitan ng x. Tignan natin. Yes, it's possible. It's possible. I mean, medyo magiging mahirap na lang siya, pero, well, ito, try natin. 1 to the 4, 2 to the 4, but first, nung some of the first n cubes, prove mo muna. But let me illustrate. Kasi given na ng formula, n plus 1, 2n plus 1 over 6, but people who devised this, saan nanggaling yun? Diba? I mean, where did it come from? Anyway, ito. N plus 1 cubed minus n cubed. Kasi diba, n plus 1 to the third power is, you know how to expand a binomial, yes? So, ano to? This will be?
N cubed plus 3n squared. Ay, hindi pa pala siya, hindi siya A tsaka B. So, wait lang So, if I is B, A squared B is 3n squared plus 3ab squared, which is 3n lang. 3n plus 1.
3n plus 1. So, that's correct. So n plus 1 cubed minus n cubed is going to be 3n squared plus 3n plus 1. All right. So in fact, ganito. If I ask you naman, what is n cubed minus n minus 1 cubed? Maybe I should have started with this. Ganito na. Itong formula, let me write this as x plus 1 cubed equals x cubed plus 3x squared plus 3x plus 1. So maybe ito ang tignan natin. Then let me erase this formula above. From the formula inside the box, if x is equal to n, then you will get this first line. Now, my next question is, what is n cubed minus n minus 1 to the third power? From the formula nga pala, x plus 1 cubed, let me write this in the form that we're actually using. X plus 1 cubed minus x cubed equals 3x squared plus 3x plus 1. What we are subtracting on the left side are cubes. But not just any cubes, they're cubes of 2 consecutive numbers, x plus 1 and then x. In the first formula, we are doing something similar, the difference of the cubes of n plus 1 and n, but in the next line, the difference of the cubes of n and n minus 1. So this time, we can
guess ko po kasi dyan, kasi parang basically, if you think of n as n minus 1 now, then n plus 1 will become n. It's just a change of variable. So if you replace n with n minus 1, it will be 3n n minus 1 squared plus 3n minus 1 plus 1.
Good. All right. So it stands to reason if you have n minus 1 cubed minus n minus 2 cubed, it will be still the same, right? Very, very similar, except that it will be 3 times the square of
minus 2.
N minus 2 plus 3 times n minus 2 plus 1. And then let's bring this all the way down to the following. 2 cubed minus 1 cubed. Or how about, sige, good muna natin for it to be a bit gentler. 3 cubed minus 2 cubed, and then, sige, ito muna. So this would be 3 times 2 squared plus 3 times 2 plus 1. And then finally, 2 cubed minus 1 cubed will be 3 times 1 squared plus 3 times 1 plus 1. At least with the last line, you can easily verify the left side is 7, the right side is 3 plus 3 plus 1, also 7. So everything's in order. Now, what we are going to do is we're going to add.
Kasi magkaka-cancel po eh.
Right. So on the left side, when you add, ano matitira?
Effect po eh. N cube will cancel and negative n cube and minus
Mhm.
1 cube. etc. So parang diagonal po na cancellation. So n plus 1 cube minus 1. Yan lang po.
All right, good. N plus 1 cubed minus 1. Now here on the right side, let's look at adding everything in the first column. 3 times n squared plus 3 times the square of n minus 1, 3 times. So see, all the terms are 3 times something. 3 times
the
what?
sum of all of the squares.
Yeah. So the sum of I squared.
They are known naman po yan sa 3 times the sum of all integers naman is 1, 1, 1, 1, 1. I get
Oh,
this.
all right. So here you get 3 times the sum. I runs from 1 to n of I. And then the last column, when you add all them up, what's that going to be equal to?
And plus
N.
1 and
1's going to be added to itself n times. Okay. Pero look here. We already know this to be n plus 1 over 2. Let's pretend for now that we don't know yet the sum for the first n squares. We don't know yet the formula for the sum of the first n squares. But if you look at this equation, that gives us a way of identifying what is this equal to. Okay, so now here's what we're going to have. On the left side, n plus 1 cubed, so that's n cubed plus 3n squared plus 3n plus 1 minus 1. And then here we have 3 times the sum of I squared. So ito na lang the sum of I squared, no, para mas madali isulat. And then plus 3n plus 1 over 2 plus n. Let's leave this here and move everything to the other side. So actually 3 times the sum of I squared, plus this 1 minus 1. So we're going to have n cubed plus 3n squared plus 3n. Tapos what are we going to transfer? We're going to transfer these to the other side. Minus 3 halves n squared minus 3 halves n minus n, which is going to give us n cubed. That's taken care of. Tapos ito, 3n squared minus, so, and then ito plus n over 2, right? 3n minus 2n, all right. Tapos the same denominator 2, we have n cubed, 2n cubed plus 3n squared plus n. You can factor out n, 2n squared plus 3n plus 1 over 2. So n and then 2n plus 1 along with n plus 1 over 2. That's 3 times the sum of the squares. So finally, the sum of the squares as I runs from 1 to n would be the formula we had divided by 2 and then divided by 3. So that's how the denominator ends up being 6. Numerator is n plus 1, 2n plus 1. Jaron, formula for the sum of the first n squares.
It's kind of,
Ayan.
it's a little, ano po siya, parang, ano po tawag doon? You need to have the previous term to get the next term. Recursive eh. It's kind of recursive po, and then it requires as I can see po, I think it needs the binomial expansion. If for ano naman po, there are infinite number of terms pag to the x power. So if it's recursive, it's really necessary to find a pattern naman din po.
But it allows you to determine also exactly. So now that we have the formula for the sum of the first n squares, okay, so for when you have the time, I'd like you to try to justify why is the sum of the first n cubes as I gave it. And then afterwards, if you are so interested, can you come up with a formula for the sum of the first and fourth powers? Okay, so parang something to parang discover, explore on your own. All right, so hindi lang basta magbibigay ako, solve this. Pero ito, this is an open-ended question. Okay, try to see ano nung kailangan to do something similar. Okay, so try to prove that the sum of the first n cubes is n squared n plus 1 squared over 4, and then find a formula for the sum of the fourth powers of the positive integers from 1 up to n. For the sum of the first n cubes, I'd like to point out that this is a nice squared quantity. It's the square of n. What's that?
I think it's related to ano po, it's related to yung I cube po.
Alam nung the formula for I to the 4?
Kasi ito po, it's the square of yung ano po, is just basically the square of yung sum of yung squares po.
No, I to the 4th. So are you pointing out how this is I squared?
Yung sa I cube po, yung it's just basically the sum of the I squared squared.
No, actually, no, n plus 1 over 2, this is the sum of ng mga i's. So kasi n plus 1 over 2, that's the first formula. The first star. So ano lang siya, 1 plus 2 plus 3 all the way to n. So we're not sparing anything yet. So in fact, this is the square of the sum of I as I runs from 1 to n. So in other words, if you look at the sum of the first n cubes, 1 cubed plus 2 cubed plus ... plus n cubed, this is coincidentally the square of 1 plus 2 plus ... plus n. Rather fascinating, at least as far as I'm concerned. I don't know if it's coincidence or it's also going to happen at some point. Okay. So in fact,
Identity na po parang ganyan.
ano yan?
An identity po na it looks like that. Baka siguro yun po pwede pong i-investigate.
Pero it's interesting, what if kunwari the exponent 3 is replaced by 4 or 5? Parang can you relate it to a power of a sum with lower exponents? I don't know. So you could verify if n is equal to 3. The left-hand side would be 1 cubed plus 2 cubed plus 3 cubed. So 1 plus 8 plus 27. So that's going to be 36. Right-hand side naman will be the square of 1 plus 2 plus 3. 6 squared, so also 36. So equal nga sila. There. Looking at okay. already familiar with arithmetic sequences and series? Are you already familiar?
Question po is,
Joshua, are you familiar?
I'm familiar po. Hindi ko lang po natatandaan yung formula for the series.
All right. Sige. Ako, ginagawa ko, so for example, so may mga easy examples. So, kunwari, -11, -8, -5, -2, 1. Tapos, it's an arithmetic sequence kasi you always have to keep on adding a constant, which we call the common difference. What's the common difference here?
3.
The common difference is 3. The common difference can be a negative number, in which case you're subtracting something. So in that case, the values will be decreasing. They will be going down. Trivially, if the common difference is 0, then all the terms should be the same because you are going to keep on adding 0. So there would be no change in value. So if a sub n is the nth term, all right, so you have a sub 1, a sub 2, a sub 3, a sub 4. So a sub 2, you can think of this as a sub 1 plus d, right? And then, kasi starting from the first term, you have to make a single jump of adding d. To get to a sub 3, you have to make another jump. And so a sub 3 is a1 plus 2d. Okay, the coefficient 2 is because there are 2 jumps that have to be made. And then from a1 to a4, you would have to make a total of 3 jumps. So a sub 4 is equal to a sub 1 plus 3d. And so in general, a sub n is equal to, can you write down the pattern? What's a sub n equal to?
1 plus 1pn minus 1 times d.
All right. Okay. And then the thing with that idea of jumps is that if you understand that, we should be easily able to write down other formulas. Like for example, how can we write a sub 7 in terms of a sub 3?
Sub 3 plus... So, hindi na po siya n minus 1. There should be a general formula. If it's
Right.
an equals am. So, an equals am plus quantity n minus m. Okay. So, for d po.
For d. Or visually, think of it this way. Here's a3, a4, a5, a6. Sorry. Wait. From A3, how many jumps do we have to make?
4.
4 jumps. So if you think in terms of, the number of jumps that you have to make. And then how about, can we write a sub 20 in terms of a sub 23?
Plus minus 3d.
All right, minus 3d. All right, so just visualize it. Parang you don't always have to anchor it on this particular formula. So, I mean, if you could think of the number of jumps that you need to make, so it'd be easier to come up with these. So, in an arithmetic sequence, if you take any 3 consecutive terms, do you see that the middle term is the average? A sub 5 is equal to a sub 4 plus a sub 6 over 2. Okay. How so?
Kasi po, A4, tapos may A6. A6 is essentially A4 plus 2D. So, A4 plus A4 plus 2D is A4 plus A4 plus D, which is A5.
So you were thinking of A4 plus A6 over 2 Kasi you were thinking A6 is A4 plus 2D. All right, good, good, good. That's a good way to go. And then when you divide by 2, we are left with A4 plus D, which is A5, right? But also, okay, A5 is in the middle. So A4 is A5 minus D. A6 is A5 plus D. All right. So when you simplify this, you end up with the same thing, A5. Right? How about ito? In an arithmetic series, in an arithmetic sequence, what is A to the 7 plus napalaki ng letter A, but A7 plus A sub 13 over 2. Can you conveniently write the average in terms of another term of the sequence?
Kasi pag lumalaki po, it's very hard to pinpoint which the middle. So I will just use A13 is A7 plus A6. So it is A7 plus 3 jumps. That is 10. Itan po.
All right. Okay.
Yes.
So kasi you could also think of it this way. From 7 to 13, how many jumps were made? From 7 to 13? 6 jumps. Right? So kumbaga you're traveling from, kumbaga you're on a number line. You are in a particular point, and then you have to make 6 jumps to get to the second point. So halfway through would be arrived at by making just half the number of jumps. So if from the first point to the last point you made 6 jumps, then halfway through you would have only made 3 jumps. So from A7, 3 jumps would lead you to A sub 10. All right.
Hindi naman po, A13 is A7 plus 6. So A7, 2A7 divided by 4, A7 lang. Plus 3B.
Yeah. Can I give you a little bit of time to think about this? And then what I'm interested in seeing is how you are going to solve this.
And fifth term. You? You ba po
Find
yun?
the fifth term. Yeah, find the fifth term of an arithmetic sequence whose third term is 35 and whose 10th term is 77.
My 10th term is 77, so I can't. So 10th term minus third term 7D. 77 minus 35 is 42. So 7D is equal to 42. D is equal to 6. So fifth term is third term plus 2D. So if the D is 6, then 2D is 12. 35 plus 12 is 4, is 47.
Yes, that's it, 47. All right. So ito, you don't, kasi the standard way that students would do is gagawin pa nila 35 is A1 plus tas N minus 1, 2D, tapos 77 is A1 plus 9D, tas they would solve a system for A1 and D. So, but you know, if you understand the relationship between these terms, that could allow you to cut some steps. So ito.
X minus 2 plus 3 and 1 minus 4x are consecutive terms. Oh, okay. So 2x plus 3 minus x minus 2 is equal to 1 minus 4x minus 2x plus 3. So
Right. Okay. That's pwede then. You're thinking 2x plus 3 minus x minus 2 equals 1 minus 4x minus 2x plus 3.
so you can just actually it would be easier to it would be easier to add than subtract. So just switch the 2x plus 3 and the x minus 2, just put them on the other side. So 2x plus 3 plus 2x plus 3 is 4x plus 6, and then the other one would be minus 4.
Actually, ganito, are you trying to solve this equation? Kasi kahit hindi na kasi, you can already solve this equation. So, you can find the value of x. Also, another point of view here would be, so you know how 2x plus 3 is the average of x minus 2 and 1 minus 4x. So in fact, pwedeng diretso ka na double the middle equals x minus 2 plus 1 minus 4x.
Equivalent po siya din po dun. Kasi,
Yeah, actually, they're all equivalent. They're all equivalent. Definitely. Tapos, all right, any questions?
4, 8, 2, 8, 3. 4, marami pa dito. What? Okay, wow. This is
Yeah.
this is kind of it took a turn. Okay.
Kasi if I'm gonna give you like the first one, kaya mo nang gawin mentally yan eh. All right, so no need to stay on that. I'll just keep on pushing you. Okay.
Okay.
But
So,
Pero you may want to write it down on pen and paper. How about ganito? I'm not going to require you to answer this now. All right, but when you get the chance, if it so interests you, pick it up when you get the chance and then answer this. All right, but before I leave this, is the notation clear?
it's actually interesting. That's
Like for
So-
example, itong a sub 2. Do you understand what that is?
it means it is the A sub 2 term of
Yeah, right. Kunwari, if a sub 7 equals 13, then a sub 2 is a sub 13. All right.
7 po.
Sorry. Hold on. Hold on. If a sub 2 is equal to 13, then a sub 2 is equal to a sub 13. My bad. All right. So that's why this was also relevant. Because you're going to use them as subscripts, so they have to be positive integers. All right. So ito, I'll leave you to it. Tapos ito, here's dami kong iniiwan na, pero okay lang, basta hindi ka mawawala ng isa-solve.
So it is the
Meron pa tayo ng mga absolute values in an arithmetic sequence. A sub 1, A sub 2, A sub 3, with A sub 16 equal to 13, and A sub 30 equal to 20. Find K if A sub K equals 27 over 2. But I think maybe the first one is a little bit more interesting. Okay. So a sequence is a list of numbers where you can generate every other term by adding the common difference. The corresponding sum is referred to as an arithmetic series. So you are familiar with the Gaussian pairing tool, 1 plus 2 plus ... plus n is equal to n times n plus 1 over 2. Familiar ka na, di ba? Kasi if you let this be s, what you need to do is rewrite in the opposite order, right? The sum is still going to be s, which means that when you add 2s and then 1 plus n, that's n plus 1. The sum of 2 and n minus 1 is still n plus 1. And in fact, everybody here, all columns are going to have the same sum, n plus 1. But how many times does n plus 1 appear? N times. So this is n times n plus 1. And therefore, the sum is n times n plus 1 over 2. Okay. Now, what about the sum of an arithmetic series in general? So say we are looking at a sub 1 plus a sub 2 plus ... plus a sub n minus 1 plus a sub n. Sometimes it's convenient to write down as a subscript for s sub n to represent the fact that there are n terms that we're adding, or rather we are adding the first n terms. Addition is commutative, so you can switch the order and then double s sub n. The first column sum is a1 plus an. For the last column, that sum is still the same, a1 plus a sub n. And then for the second column, The thing is, if you look at a sub 2 plus a sub n minus 1, a sub 2 is the term after a1. So a1 plus d. A sub n minus 1, on the other hand, comes before a sub n. So that's a sub n minus d. So starting from the leftmost and rightmost extremes, a1 and an, to get to a2, you have to add a single d. From an to get to a sub n minus 1, you have to subtract a single d. So the number of d's added is the same as the number of d's subtracted. So the d's are going to cancel. This is still a1 plus a sub n. And by a similar argument, every other column will have a1 plus an as sum. And this appears n times. So therefore, the sum of the first n terms is a1 plus a sub n multiplied by n, because that's the number of times this sum appears, and then divided by 2. You have seen this before, Joshua?
This before, but I did not memorize it.
All right. Ayun, actually, there is another formula, but this is what I primarily memorize. It's based on the Gaussian pairing tool. So you add the first and last terms. So parang in 1 plus 2 plus dot 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 plus n. So you have the formula n times n plus 1 over 2. So if you add the first and last, 1 plus n, that's going to be n plus 1. That corresponds to adding a1 and an. So ito yun, a1 plus a sub n. And then multiplied by n, how many terms there are, divided by 2. So the picture I always visualize is actually the Gaussian pairing tool. I imagine these columns, and I know the sum of each column, a1 plus an. And how many times does it appear? It appears n times. But then that's double the sum. So therefore, divide by 2.
That's for ano po, no? Yung even number of addends na po.
Not really.
Actually, even if odd number of addends, kasi kunwari you have a1 plus a2 plus, actually nung una nga din yun nung iniisip ko a1 plus a2 plus a3 plus a4 plus a5. Pero mangyayari, even if you write it as okay, mangyayari, if there are an odd number of terms, so you're gonna get double a3. Okay, pero remember, if there are an odd number of terms, the middle term, a3, is the average of the first and last terms. So kasi between a1 and a5, a3 is right there, smack exactly in the middle. So therefore, the middle column will be double a3 when you add, but then that's still going to be a1 plus a5. So hindi mag-break ng pattern, whether you are looking at an odd number of terms or an even number of terms. So valid pa rin siya. So even if n is odd, so it's still valid. Ito, an easy exercise. Find the sum of all multiples of 6 between 22 and 345.
Okay, so 360. The one behind that is
So sige, think about this, Joshua.
and then 348. 348. Okay, so 342. 342 is the last. Okay,
Right. So what's the first term?
24 and 342. 24 to 342. So,
All right.
how many terms are there? 342 plus, ano? How do I find the middle?
So your question is, so how many terms? You're right. That's what we need to figure out.
Plus 366 in total divided by 2 is 188. I will make a smaller example. Let's say it's from 24 to
No, 100.
so, 24 to 24. I'll make a very small example so I can visually count it. 24 to 42. 24 to 42. So 24 plus 42 is 88. Divided by 2 is 44. So that's not the middle term.
No, number of terms.
No, how do I find the number of terms? Wait. 24 plus 42 is 88. What? 24 plus 42 is 66. And then 66 divided by 6 is 11. 24, 30, 36, 42. So there's actually no middle term. Be 4 terms. 24 plus 42 again, 66.
Difference.
But it's 42 minus 24. 42 minus 20. 18 yes, 18. 18 divided by 63 plus 1. Okay, so I'll try that here. 342 minus 24. 318. 318 divided by 6 is 53. 50 plus 1 is 54. So there are 54 terms. 54 over 2 is 25 plus 7. 27 times whatever 24 plus 3.2 is. So that's 366. 366 times 27. So
Okay,
that's
na.
3. And then
Okay, na. I mean, I know you can compute. So you're right. 27 times 366. So I have it on my calculator. 9882. All right. So right now I'm gonna. So tama. Okay, good. You were able to figure out how many terms there are. But alternatively, if it helps, no. Also, because these are all powers. Because these are all multiples of 6. If you want, you can factor out 6. 4 plus 5 plus dot, and then 342 divided by 6. So that would be 57. Right, so alternatively, you could maybe add these first. So I mean, you could add it as an arithmetic series. 4 plus 57. So the determination of the number of terms 54 would be so much easier then as well. That there are 54 terms. Kasi mas kita eh. Or pwede din, alternatively, you could think of this as 6 times 1 plus 2 plus dot plus 57 minus 6 times 1 plus 2 plus 3. All right, kasi ito 6 times 57 times 58 over 2 minus 6 times, you hardly have to use the formula 6 times 6. All right. Of course, all these are equivalent. All these are equivalent. Okay, that they're gonna lead to the same answer. The sum of the first 7 terms of an arithmetic sequence is 49, while the sum of the first 17 terms is 289. Find the sum of the first 24 terms. All right. So I have a meeting at 3:30, and it's practically, well, it's 3:19. So do think about all the okay, maybe let me write one more.
Let me anak ni sir.
All right. So the sum of the first 2 terms of an arithmetic sequence is 9, and the sum of the first 3 terms is also 9. How many terms must be included, starting from the first term, to get a sum of negative 126? All right, so it's all gonna be here. All right, so I hope Joshua and sir, you learned something new today and you enjoyed it. All right.
So enjoyable po.
All right, ano, may natutunan. So I hope may natutunan ka naman, Joshua, from what we did today. All right, new things, uncomfortable things, or unfamiliar things. All right. Okay. So yeah, enjoy the rest of the day, Joshua. Okay. Then just always ask by Facebook if you're stuck with something. Don't wait until the next time we meet. Like, you just need like maybe a hint or a clue or just something to something you need to progress. To just ask. Okay. Bye.
Bye po.
Bye bye. Bye.